What's up, guys? Today I'm going through the final unit of this lesson, which is 0.6, inverse trig. Today we're just going to cover the definition of inverse trig and inverse trig equations. So the definition, think of inverse cosine of x equals y as what value will make cosine of that equal x. So basically, inverse cosine of 1. Well, when is cosine going to be 1? When x is 0 degrees. However, it can also be 0 at 2 pi, because after you go around the circle, you're back to where you started. And it can also be 0 degrees at 4 pi. It can also be inverse cosine can be 1 when theta is 0, 2 pi, 4 pi, or negative 2 pi, negative 4 pi, and so on and so on and so forth. However, now I tell you this is a capital letter. It's going to be restricted to a certain domain, which is 0, pi. And sometimes the interval where the function is restricted to make it a function depends. Sometimes it can be negative pi over 2 to pi over 2. Sometimes it can be 0 to pi. The reason why the interval 0 to pi over 2 is always included, the answer is because we like the first quadrant since everything's positive. So here you can get an idea of the different types of graphs and where they are bounded between. The sine function is bounded between negative pi over 2 to pi over 2. So are the tangent and a cosecant. Cosine functions, however, are bounded from 0 to pi. Because if they were bounded from negative pi over 2 to pi over 2, we will only have positive values. We need negative values for inverse cosine. And we choose quadrant 2, 1 and 2, rather than quadrant 4 and 3, because we always like quadrant 1. Inverse cotangent is bounded the same way as inverse sine. Wait, my bad. Oops. My bad. Made a mistake here. Inverse cosine, because inverse cosine of 1 is 0. Inverse cosine of pi of negative 1 is pi. Because what value cosine of what is negative 1? Pi. So you can see tangent and cotangent are kind of the same ideas. And then because inverse cosine is like that, inverse secant must also. So yeah, that was a catch on me. So inverse tangent, well, because you start at negative infinity when you're at negative pi over 2. Because you can just look at sine over cosine. You start with negative 1 over because at 0, you're at doing 0 over 1, and at 1, and basically as you just get to pi over 2, you go towards 1 over 0, which is infinity. So yeah, these are just the ways you can think of the inverse trig functions. Think of the inverse trig functions as just graph the normal functions like the trig functions. And yeah. Now I want to get into the inverse trig equations, which is basically just a nice little combo of algebra and trig together. So let's do a problem that I'll make up arbitrarily. And there are some tips to solve this. So what we can do, treat the cosine x as our x. We can factor this as cosine x minus 1 squared equals 0. And for these, assume your domain is 0, 2 pi, but 2 pi is not included. So cosine x minus 1 equals 0, cosine x is 1. For what value is cosine of x equal to 1? Only when x is equal to 0. That was a really easy problem. Now let's solve this. Cosine squared x is a half. That means cosine of x is a square plus or minus the square root of 1/2, which is plus or minus root 2 over 2. Notice we must have a plus and minus, because if it's only plus, then we don't. If it's only a plus sign, then we forgot half of the solutions, because negative root 2 over 2 squared is half. So when does cosine x equal root 2 over 2? And when does cosine of x equal negative root 2 over 2? The first part is true at pi over 4 and 7 pi over 4. You might be tempted to say negative pi over 4, but negative pi over 4 is not in a domain. When does cosine x equal negative root 2 over 2? 3 pi over 4 and 5 pi over 4. So here are your 4 solutions. Sometimes these equations can have many solutions, so beware of that. Now let's do something a little even harder. I gotta find something. Let's do cosine squared x equals 8. That means cosine squared x must equal 2. And cosine x equals the square root of 2. However, here's a problem. When cosine can never be greater than 1 or less than negative 1. And as a result, this has no solutions. Now let's do something else. Cosine of 3x must equal half. So we know 3x equals the inverse cosine of half, which can be pi over 3 or 5 pi over 3. The interesting thing to note about this is that pi over 3 and 5 pi over 3, they must add up to 2 pi. When you get 2 solutions for cosine, they must add up to 2 pi. Now we do 3x equals pi over 3, and x is pi over 9. 3x equals 5 pi over 3, and x is 5 pi over 9. But here's the thing. Remember how we can always add 2 pi n? Now we can also add pi over 3, 2 pi over 3n. on both sides. So that means we have 7 pi over n and 13 pi over n. And on the other side, we have 11 pi over n, 17 pi over n. So as a result, we got 1, 2, 3, 4, 5, 6 solutions. Wow. Who ever thought we could do something like that? Well, this is trig, and that's what happens. Now, I want you to try something. How many solutions are there in this? I want you to solve this. No. So cosine 2x minus 1. Well, cosine of x minus 1 has one solution, meaning cosine of 2x minus 1 will have two solutions. 2 sine of 2x minus 1. 2 sine of x minus 1 0 has two solutions. So if you have a 2x, then it's 4 solutions. On the tangent side, tangent of x equals 0. When is that true? When x is 0 and at pi. That's 2 solutions. 9 secant x minus 5. So when does secant x equal 5 over 9? Well, here's a problem. Secant is 1 over cosine, and that means cosine x must be 9 over 5, which can never happen. So there are 0 solutions. In total, there are 2 plus 4 plus 2, which is a total of 8 solutions. My apologies. Oops. That's how you solve trig problems like that. Trig equations, I mean. Thank you for watching, people. This was a good video, and I hope you learned. Next up, we got Unit 1, which is limits.